Today we'll be discussing research on a ground-penetrating radar survey at a site near Dewey, Montana in the Big Hole Valley. This site was chosen based on a pedestrian survey conducted by archaeologists from the Montana Bureau of Mining and Geology and Montana Tech. What they discovered was numerous surface artifacts relating to prehistoric Native American occupation of the area. Thus, the site was chosen for an archaeological excavation operation. Ground-penetrating radar is a near-surface, non-invasive geophysical exploration technique, which applies a transmitting and receiving antenna. The transmitting antenna emits an EM wave into the subsurface, which makes contact with electrical boundaries, producing a reflection measured by the receiving antenna. Moving on to survey design, a 6-meter wide by 16-meter long survey grid was laid out near a natural spring in the area, which was often occupied by Native Americans prehistorically. 12 GPR profiles were measured, with 50 centimeter spacing in between them along the width of the grid. Then, every 5 centimeters, measurements were taken along the length of the survey grid, with 400 megahertz unshielded antennas. After the 12 GPR profiles were collected, we move on to processing. A 4-step editing process was conducted for each of the 12 GPR profiles. First off, we would adjust the signal position, which allowed us to set time 0 and account for the separation between transmitting and receiving antennas. Next off, we move on to trimming the time axis, which allows us to remove these unnecessary standing waves at the bottom part of GPR profiles. After removing the DC component, we are able to remove the global background, which allows a view without this strong horizontal banding on unprocessed GPR profiles. After we were done processing, next was converting travel time to depth. This requires a 1D velocity model and calculating the half-space velocity or the electric magnetic waves velocity through the subsurface. In order to do this, we conducted a common midpoint test, which retrieves a reflection from a common point in the subsurface. Here we see our common midpoint test GPR profile. Now, we take data relating to the travel time and antenna separation distance, square it, and plot this data. Once applying a linear trend line to it, we can pick off the slope. Now the slope relates to our electromagnetic waves velocity through the subsurface. By that, 1 over the square root of the slope is equal to the velocity. Now after collecting our velocity through the subsurface, it is easy to do a depth conversion, and so we move on to our interpretation of GPR profiles. There was 3 features that we focused when investigating a GPR profile. First off, highly reflective, closely spaced reflections, which we observed in profile 7. Near about 14 meters along the length of the survey grid, we pick up some strong reflections that are closely spaced to each other. Now, once excavated, what this correlated to was a stone fire hearth used prehistorically by Native Americans. Alongside this fire hearth, we see that there was numerous artifacts discovered. And this shows that often Native Americans would work their tools with the aid of fire and firelight. Moving on to our other 2 interpretable features, there was the grouping of various materials relating to an accumulation of either artifacts or fire-cracked rocks, which we observed at the near side of our profile 3 around 2 meters. Next, we can also pick off highly reflective, closely spaced vertical striations, which related to bone groupings, often at the top part of GPR profiles. From our excavation and results from picking off this grouping of various materials is that we discovered numerous prehistoric artifacts relating to stone knives, projectile points, scrapes. This is a preferred manner of viewing GPR when seeking targets that span over several adjacent profiles. Interpolation occurs in between the 12 GPR profiles, and one improvement that we can make to this research would be spacing our GPR profiles closely together. Rather than 50 centimeters, we could have done 10 centimeters, improving our horizontal resolution. Finally, we conclude that this site was used by Native Americans for processing game and wild animals